Now we're going to look at the washer method, rotating the area around a line parallel to the y-axis. So this is a lot kind of combining the methods of the last two videos of rotating around the y-axis and rotating around a line parallel to the x-axis. So it's just kind of combining the two, and yeah. So our first example is the area bounded by y equals x and y equals 2 times square root of x being rotated around x equals -2. So again, notice our function on the right will be f of x, big R, which is y equals x, and our function on the left, g of x, or little r, will be y equals 2 rad x. So we're going to need to find a and b first, as always. So I went ahead and set our two functions equal to each other in order to find the x point at which they intersect, and we end up with x equals 0 and x equals 4, and again, because one of our functions is y equals x, we end up with the same y values as x values. So our limits of integration is a is going to be 0 and b is going to be 4. And the second thing we have to do is rewrite our functions in terms of y. So the first one is just going to be x equals y, and then y equals 2 rad x is going to turn into y squared equals 4x, and x will equal y squared over 4. And that's what we're going to use to integrate. So I went ahead and set up the integral, and what you'll notice is similar to when we rotated around a line parallel to the x-axis, there's going to be an extra term added in here. So the radius is going to be from, in this case, f of x all the way over to -2. So we have to include the equation minus -2, and that's all squared because that'll give you that whole radius. So it's going to be y minus -2 squared minus the quantity of y squared over 4 minus -2 all squared with respect to y. And it'll all look like that. So again, now it's the same process, and you just have to simplify. So we'll go line by line. So you'll end up with y plus 2 squared minus y squared over 4 plus 2 squared. And then multiply both those out, you get y squared plus 4y plus 4 minus quantity of y to the 4th over 16 plus y squared plus 4, integrating it with respect to y. And then you can combine the two terms. You'll get v equals pi times the integral from 0 to 4 of -1 over 16 y to the 4th plus 4y with respect to y. And then integrate it, get v equals pi times the quantity of -5/16 y to the 5th plus 2y squared, evaluated from 0 to 4, and your answer is y equals -288 pi. And now for our second example, it's going to be the area bounded by the graph of y equals 9 minus x squared, rotated around the line x equals -2, but only for this interval 0 to 3. So our graph is going to look like this. So the only area we're using here is 0, x equals 0 to x equals 3. So when x equals 0, b is 9, and when x equals 3, a is 0, which I'll just show here by substituting in. So when x equals 0, you just get y equals 9, which is actually going to end up being b. And when you input 3, you get 9 minus 3 squared, which equals 0, which is going to end up being a. So those give you your limits of integration, and you basically just do the same process as the last question. So the first thing you have to do is write the equation in terms of y again. So you'll just rewrite this and end up with x equals the square root of 9 minus y. And then what you have to remember is there actually is two functions, or not two functions, but two radii here as you're rotating. you have the big R, which is just your function here, minus -2. And then there's this. The x-axis, when you're rotating it, it creates another radius. So it would just be 0 minus -2. The distance between that is only 2. So you just have to remember to include that in your integral. So you'll write v equals pi times the integral from 0 to 9 of the square root of 9 minus y minus -2 squared minus 2 squared, because the distance between those two is just 2. And then you'll rewrite them as 9 minus y to the 1/2 plus 2 squared minus 4. And then you'll multiply the first term out as 9 minus y plus 4 times the square root of 9 minus y plus 4 minus 4. So these two 4's will be negated, and you'll end up with -y plus 4 times the square root of 9 minus y plus 9 with respect to y. And you'll be able to integrate from there and get v equals pi times -1/2 y squared minus 8/3 9 minus y to the 3/2 plus 9y evaluated from 0 to 9. And your final answer will be volume equals 225 over 2 pi. So that is the basic gist of the washer method. There's more complicated problems as the functions get a little crazier. They can get longer and more annoying, but that's basically most of the types of problems you will see. And yeah, thank you.